We have been using functions like min, max, length, among others. These functions abstract the implementation details of the algorithm that helps us carry out computation on data. This makes the function useful as a reusable block of code. For instance, we can just call the min function on any numeric vector regardless of the length of the vector, and because the function encodes the algorithm that computes min, the function will always return the mean of whatever numeric vector we pass as argument to the function. In this video, you will learn how to create your own functions. R provides a template for function definition. You will always use this template when you create a function. You must define a function before you can use or call the function. This is the template for function definition in R. A function is an object. You will create a variable that will refer to a specific function object. A function object is preceded with the function keyword. You will provide arguments within parentheses and procedures or algorithm for computation within the curly braces. You will use the variable to call the function when you want the function to execute the algorithm or procedures that are defined for that function. For instance, to create a function that will add two numbers, let's call the variable adder. This adder gets function with two arguments, num1 and num2. The code or algorithm that the function will execute is num1 plus num2. That ends the function definition for adder. Let's execute adder on the console to get the definition into the environment. This function is now in the global environment, and you can see adder, which refers to this function. To call adder, we'll use this code. So let's add 5 and 8. The result is 13. Note that although we have defined these arguments as num1 and num2, and in addition we have called the adder function by providing 5 and 8, which looks like integer values that are by themselves. Internally, 5 and 8 are represented as vectors, and the computation num1 plus num2 is internally implemented as the addition of vector. This concept is actually referred to as vectorization. Because of vectorization, it is possible to add vectors of more than one length using the same function. So I have adder, but this time the first argument is clearly a vector. The second argument is also a vector, but not so clearly a vector. Okay, so let's hit enter on the keyboard. So 6 is added to 3 to get 9, 6 is added to 4 to get 10, and 6 is added to 6 to get 12. This concept of vectorization is referred to as broadcasting. What if we provided two vectors with equal length? This time 6 will be added to 3 to get 9, 3 will be added to 4 to get 7, and 2 will be added to 6 to get 8. So we should have 9, 7, 8 as the answer.